Hey, and welcome to Field Trip Friday. So some weeks we're going to be out in our mountains, and some weeks we're going to go on trips to some of our labs so that you all can see how I use my geologic knowledge to actually do the research and the work that I do. And so this week in class, we've been talking about mineral properties. And so what I'm going to talk to you about today is how we can actually use those mineral properties to separate out and find particular minerals that we might be interested in. So the mineral that I am interested in is zircon, and this is the same thing that you might see in a ring that you might have heard of as cubic zirconium. So zircon is a pretty hard mineral. It's nice and clear. It has a really pretty crystal habit, so that's why it can be used in place of diamonds sometimes, and people do that again in rings and in jewelry. But I like zircon for a totally different reason. The reason that I like zircons is that uranium likes to substitute in the zirconium space in that grain, and uranium is a radioactive element. So uranium decays to lead over time, and I can use what I know about that decay rate and the ratio of uranium to lead in my zircon crystal to tell me how old that grain is. So this is something that I do a whole bunch in my job, and we'll talk about this some more in the future when we talk about how and why we do dating of different types of minerals. So that's why I'm looking for zircon, and now I'm going to show you a little bit of how we look for zircon. And so zircon is special in a number of different ways, and one of them is that it's a relatively dense mineral. So what that means is that, right, the same size grain of zircon is going to weigh more than an equal size grain of, let's say, quartz, for example. And so I can use that to my advantage, and I can try to separate out my dense minerals from my light minerals. And then I know that my zircon is going to be hanging out with all my dense minerals, whereas my quartz and feldspars and other things I'm not interested in are going to be hanging out with other light minerals. And so the process that we use in order to do this is actually the same as what we would do if we were panning for gold. And so panning for gold works because gold is really, really dense. And so, again, we can separate out dense minerals from light minerals, and one of those dense minerals happens to be gold. In my particular samples, I'm not looking for gold. I don't think we're necessarily going to find gold in them, but I am looking for zircon. And so I'm going to use the same process of panning for them in order to try to separate out the zircon from the rest of my minerals, and then I can take all of those heavies, and I actually go through a number of other separation steps to get just zircon at the very end. So there's a couple other steps that I'll do following my water density separation, which is what we're doing. So here I am with my gold panning or zircon panning setup. And so again, this is the exact same kind of pan I would use if I was trying to separate out for any type of dense mineral. And the way that this works is in water, or in anything, but in water in particular, you can kind of force it to happen a little bit faster. When I shake this, what's happening is that all my grains are getting mixed up and jumbled. And my grains that are denser are going to be sinking to the bottom, and my grains that are lighter are going to be floating to the top. And so that's just what happens all the time, right? If I dump a whole bunch of sand into the water, my denser grains are going to sink first, my less dense grains are going to sink later. What I can do is not only do I want to shake this, but I'm going to slowly start tilting my pan. As I do that, my lighter grains are going to be sliding faster towards the front side of my pan, and my denser grains are going to be held back because they're heavier, right? So they're going to sit back. And so through this process of kind of shaking and tilting, I can speed up my separation process, and I can make it go a little bit faster. So let's see what we can do here. if we take a little bit closer look at this, so I don't know how, again, your light is going to be. Okay. So we can see on this back edge, I've got a whole bunch of dark material. Now those are going to be all of my mafic minerals, which are more rich in iron. So they're going to be denser, and they're sitting back there towards the back. Other things that we can actually potentially see in this sample is we do actually have some pyrite and other sulfide type minerals. So you might see some little metal looking faces glinting back at you. And those are also kind of collected along this back edge in here because those are more dense minerals. Again, they're not the ones that I'm looking for in this particular case. Zircons are hard to see because they're just nice and clear. But once I have this through another couple of separations, I'll take out all the pyrites, I'll take out all the mafics through those other separation steps. I'll end up with just a really clean set of only zircons out of this sample, which are what I want so that I can figure out the age of the grains within this unit. Yeah, that wasn't a bad separation. Not beautiful, but not awful.